Okay, so we have already talked about the change of state and change of temperature. However, about the change of temperature, the kinetic energy part, we have to talk slightly more about it now. Okay, you will think, okay, for two objects, for example, here, I have drawn, let's say one object is made up of 4 molecules, the other object is also made up of 4 molecules. But the one on the left hand side, the molecules move slower. And on the right hand side, it moves very quickly. In each second, it go all over the place, although they spin about the same fixed position, but the vibration is very fast, okay? So we have high temperature. And you will ask, are there any limits? When it moves faster, the temperature increase. Is there a limit? When the molecule moves slower, the molecule have less energy and the temperature is lower. Are there limits? The answer is there is no limit for highest temperature. For example, we have 37 degrees Celsius body temperature, but the sun has 6,000 degrees Celsius, and if it is moved even faster and faster, I think very close to light of the speed of light, and the mass is great, there is no limit for the fast end. However, there is limit for the lowest temperature, because when the molecule gets slower and slower, the slowest state is there is almost no vibration at all. Okay, it's like in the science fiction, it says it frees you so that your time is frozen and cure your diseases 100 years from now. That absolute zero, some of you should have heard of it. 絕對零度, absolute zero. Well, if we are using the Celsius temperature scale, the number is somewhat close to -273度, -273 degrees Celsius. It is -273.5, something like that, whatever. But this is the lowest limit of temperature, because when the molecule doesn't move at all, then the temperature measured of the average kinetic energy is very close to 0 Kelvin. This is another unit for temperature, and in Celsius scale it is -273. Okay, so we cannot decrease to a value lower than that. If we draw a diagram of the curve, it should be like this. Maybe later. I don't want to confuse you right now. Okay, let's have a look at something practical. The unit. Okay, when we are measuring energy, the unit of energy is Joule, Joule, and the symbol is J. Okay, 焦耳. Some of you play with toy gun, and then they have a different level of energy of a toy gun. But if the energy level exceeds 2 joule, 2焦耳, then legally you cannot keep it because it is classified as a weapon. Okay, so you will have experience energy level measuring in joule. Okay, but sometimes the number is very huge. So scientists come up with these tools, kilojoule and megajoule. 1 kilojoule is 3 zeros, so 1000. And 1 megajoule, MJ, it is 60. Okay. You will make use of this when you are doing the questions and homeworks and things. Just have an idea. Okay, and then the next part, we would have to address another part. It is the mass. Let me find here. The internal energy depends not only on the temperature, it depends also on the mass. Well, it is very reasonable because if 1 cup of, let's talk about the temperature first. You already know that if we have the same volume of 2 cups of water, 25 and 80, the left hand side one has more energy, this has less energy. But if they are both at exactly 25 degrees Celsius, the average kinetic energy is the same. All the molecules are vibrating at 25 degrees Celsius. But since on the left hand side, for example, let's say here it is 4 liters of water and here it is 1 liter of water, each molecule has the same amount of energy. But the left hand side, the full bucket of water have 4 times many of the molecule. So if we are considering the total internal energy, then the 4 liter bucket have 4 times that of the 1 liter cup, okay? Because the internal energy depends on both the temperature and the mass. Let me take away the joule. Okay, the internal energy depends on both the temperature and the mass. Whatever. Oh, no. Go back. Okay. Yeah, that is it. And let's do some clear up of our mind because there are lots to take in, a lot to learn, and I would like to go through this checkpoint with you. I think the video is not too long yet. So, true or false, when the temperature of a body increase, so the temperature is the measurement of average kinetic energy. So when this increase, the kinetic energy of its molecule increase. True or false? Well, you can say it is true. Apart from one case, because for average measurement, yes, but apart from, I mean, if the whole society is getting rich, there can still be people being very poor, right? So in general, true. When the temperature of a body increase, almost everyone is vibrating faster and have a larger kinetic energy. However, there are possibility that several of the molecules can be slower than before, but it's not the overall picture. Okay, so without making things too complicated, the answer for this question is true. Okay, and then the next one, Tommy says the object is extremely cold. Which of the following cannot be the temperature of the object? Okay, the mindset of this question is that cold is a relative concept for everyone. So for some people, 13 degrees is very cold, very cold. For some people, it have to be 0 to be very cold, and negative 30. So seems that all of them are possible. It's just how do you feel and what temperature you will classify as very cold. However, there is an odd one out, which is this one, negative 300 degrees Celsius, which when we have already learned about absolute zero, absolute 絕對零度, the value of the lowest possible in Celsius is negative 273 degrees Celsius. So this is too cold. It's not physically possible. Okay, negative 300 is not possible. So this is the answer of question 2. For question 3, which of the following statement is incorrect? Okay, so you would expect only one of them is incorrect, and so I will have to explain A, B, C, and D to you. But this is perfectly okay. Let's have a look. The molecules of gas are very far apart and move at very high speed. Okay, that is very true. In gas, they are far apart, yes, and very high speed, yes. Okay, this is true, so it's not the answer. And when the temperature of the body rises, the molecule of the body move faster. Is that correct? Yes, this is also correct because the temperature is the measurement of average kinetic energy. So when the temperature increase, the movement speed also increase. This is also correct. And then C, the temperature of body is a measure of total kinetic energy. This is not correct because total kinetic energy is not the temperature. Okay, temperature is the average kinetic energy. So for this example, the total kinetic energy is different because you have 4 times the molecules and the energy you have is 4 times. However, the temperature is the same, the average kinetic energy is the same. Okay, so this is wrong. Average. So the answer is C. Okay, but let's have a look also at statement D. If 2 bodies have the same temperature, the molecules of these 2 bodies will have the same average kinetic energy. Okay, that is also correct. If 2 sets of body, let's say here, if I duplicate that, if these 2 sets of body have movements of the same speed, then the energy level is also exactly the same. Okay, that is the concept being clear out, and thank you for your attention.